Hi, welcome to CNC Rotor Notes. Today we're going on a little bit different tack. I'm going to have a look at the DROs we put here on Grizzly G0704 mill. What I bought was the 4-axis set, and that gives me readings on the X, Y, and on the Z axis it's on the quill here, as well as on the main head when it goes up and down. So there's a DRO here. It's one mounted right here, one here on the front, and one here on the side. We'll go over how all those are set up. The 4-axis DRO has a setting where you can actually sum two of the axes. So this one, you can see the Z changing up here. Also, when I move this one, it changes. So it's adding those two axes together. So you end up with 3 real axes that you're reading, but it's coming from 4 of the DROs. So that's pretty cool. When I put the one here on the X-axis, I used the two mounting things. There's a little T-nut slot kind of thing here. I mounted it in there. And at first I was afraid to drill holes in this metal, but doing the rest of it, drilling and tapping these holes, it's extremely easy to do, so it's no big deal. But it's the first one I was doing. I did this axis, and then I actually used these readings on this axis to build the components for the Y-axis, and then did the same thing here. The quill was the most complicated. I had to take a bunch of pieces out. So we'll go over each of these axes in detail and see how they work. We'll start with the X. The DROPRO system, I guess, when you get it in a box, comes in a great big box. You have all the scales and everything. Comes with a whole bunch of little aluminum brackets and components like that. These are the ones I didn't use, but they're all sort of like a Lego set that you can kind of put together and just figure out the best way to make it work for each of your axes. This one's supposed to be for the quill. I'm not really sure how that was supposed to work. So what I ended up doing was sort of trying to keep a couple of rules. Trying to keep the scale as long as possible every time. I wanted to cut as little as possible off the scale, and trying to use as few pieces as I could so that I was sort of saving in case I needed a piece later on. So the first piece here is kind of an L-shaped bracket that fits right in here, and it's designed so that if you mount the scale on a piece of steel and you mount this on that same piece of steel, that the L part that comes out and up and hooks onto here is just the right depth to hold the scale at the right distance off. There's a whole little tricky thing here. When you're mounting these, there's a plastic card here. It looks like something you throw away, but you're supposed to put that in underneath there, and you mount it so that that sets the distance for the reader from the scale itself. And so that's in underneath there. You set it so that this kind of slides back and forth just a little bit. Like you can move it, but it's good and snug, and that's how you know you got the right depth. And with this one here in particular, there's 4 little holes for set screws that you can adjust the big bolts and then tighten in the set screws and get the depth set right and get the angle proper. So I used that one piece there. And there was one hole that was, I was still afraid drilling holes. So there was a scale kind of piece here. There's a ruler underneath there, and it was a bracket here that a little, I guess a little pointer here to read. So I went and removed that, and I said, okay, I'm going to use that hole, and then I center punched this hole just a little bit over to the left. So, you know, ideally this would be centered, but it doesn't really matter because I'm at the end of the travel now. And I still have 1.5 inches. I could go further here, but that's not used. So took this off, mounted this bolt and then put another one beside it. And I think these were 6mm. So drilled and tapped that hole. And I just drilled that with a hand drill and then tapped it in. It was no problem at all. And so that gave me my X scale. Now I had to cut these scales, and that's something that is kind of worrisome, but the thing to do is remember that they tell you to mark. These scales have a little some little black lines here, vertical black lines, so you want to make sure that those go in the same orientation. So I marked the scale so I knew that those would go back there. And then I wanted to cut the other end, and there's a little metal sort of fitting right here at the end, and there's just a couple of screws here you undo, and again these have 4 set screws that you can adjust the angle and whatnot. So I took these 2 screws off, and then you end up with this. So this is sort of a piece that was cut off one of these. And then there's a little stainless steel piece here. Just take that out, and you'll later just cut that with a pair of tin snips. So it's no big deal. And then you have the actual thing with the little magnetic thing here that has actual distance markers in there. So what I did was I just took this to a chop saw with a metal cutting blade, cut it at the right distance. Always trying to keep these as long as possible. So always erring on making them as long. And here's this one here. It's way longer than it has to be, but if I want to use it in the future on something else, I have it as long as can be. And then the extrusion has some little round holes there, so you just tap those again, and so it's all pre-drilled. You just go in with the tap, and that marks, and that's how this thing fits back on. The cap fits back on. So you have to account for that there's going to be a cap when you're measuring it, the distance of the cap extra. So you take the width that you got here, take off that distance of the cap, that's how long you cut it. Cut that bit off of there, and then tap it and put the cap back on. So it's pretty easy to mount that. You know, first one's kind of scary, but then you get going and it's no problem at all. Alright, you can see the L-shaped bracket coming out, going up here, and then this is where it had to be trimmed a little bit just to get it to the right height, so that the reed head would be centered in the scale. And these are the 4 little set screws here. Then for the next axis here, it's pretty tricky because it's on an angle. So there's this piece moves back and forth. This is fixed. So I mounted this here, and I mounted it kind of down as far as I could, still keeping on the flat part. And then figured out, basically it went right in the middle of this part here. So it's right sort of underneath that, where the crank would be here. And the crank goes fine there. I could put it back on. I just haven't bothered putting it on that end. And so it's right centered there. And I made I had a block of Delrin here. So let's put like a plastic material like this. And this is an extra one I had left over. The block I ended up using in there is about 22 millimeters high, and it's about 2.5 inches or 65 millimeters wide, and it sticks out at 40 millimeters. But it's cut at an angle, so it's a little bit wider than this piece here, but it's cut at an angle there, and that angle matches this angle here. And measuring that, it's you know, holding up my scale on here, it really seems like it should be 60 degrees, but measuring it and what's really, it's perfectly, you want it to be perfectly perpendicular here when you're adjusting this down on it, and I'm finding that 58 degrees is better. So maybe it's just something in the sand casting or whatever they did here that's a little bit off, but to me it just measures out at 58 degrees. Your angle may vary. So I got that piece in there, and there's a little bit of difference here between the bottom and the top. The bottom sticks out a little bit further. So I machined off just a little bit across there. So there's like a little, maybe 2 millimeters. And then while it was still square, I drilled, so I cut it to 40 millimeters. So I had a little 40 millimeter block like that. And then I drilled 2 holes in here, and for the mounting screw, which I think was a 4 millimeter or a 6 millimeter. I'll look it up in a second. And so I made 2 holes the right diameter, and they're sort of towards the top, so it would be centered in this area right here. So I made 2 holes that would be centered right in there, and centered on the center of this thing. And then I counter drilled them down so that they were with a bigger hole, so that the cap screw head would fit right in there. So it's drilled maybe to 10 millimeters with the appropriate size for whatever 4 millimeter screw, and then it's drilled a little bit bigger for clearance for the cap screw, the cap of this screw there, and then so that fit right in there. So you can imagine then, so it's got this angle, and then the 2 screws going in, and then I drilled 2 more holes. So, and I matched them up with one of the brackets that came. So it has sort of like it's a little metal piece here that screws together with this one. So it's I made the holes the right distance apart for that. So now I have a piece that can go in and slide up and down that way on that angle, and I have another piece on the end of it that can slide in and out, and that's perfectly perpendicular to the DRO. Here's the block for the y-axis. You can see here it's got that 58 degrees. You can't really tell, but it's a little bit beveled off here, just on the lower part of it. There's a hole here, that's where the bolt goes through into here, and then there's 2 other holes here that on the angle have been drilled and tapped for these bolts here. So I could move this in this axis, I can move this in and out, so that allows it to set up perfectly to match on the DRO scale. So here's the quill reading right here on so I've got a scale mounted here, so I had to replace the stock plate. So there was a plate that went on here, had a little hole cut out for the DRO that comes with this unit, and it's just a simple little DRO. Has a 4-inch play, 4-inch range of movement, but it only uses 2 inches, since this can only go up and down by 2 inches. So I replaced this with a piece of aluminum plate here, and then I cut a hole out of it, so that basically about the size of this hole here, so that this could move up and down in there. Here's the reed head mounted there, goes up and down, and the scale is mounted right here, and I've got a little aluminum block behind there and a hole down here. It's just tapped in. Now down below here there used to be a plastic block, and this plastic block attaches to a flat spot here on the quill, and it came out, and then there's a little hole right here where it attached. So basically it was through the same two holes, so I reused those holes, and it would go up and down and pull the slider up and down for the DRO that was built into here. So I took all that out of there, and then I made a little aluminum angle assembly here. So there's actually two pieces of aluminum, one and then another one that comes out. So we'll look at those from the side to see how they work. And the two of these combined together give me a place to mount this, which is another one of the pieces that came with the kit, and that's used to mount that. It's got the right holes here. I machined this out a little bit wider, so I had something here with a little bit of play so I could move it back and forth. I think there was two holes that looked like that, so I just used the mill and made that a little bit wider. So you can see here attached to the quill is a piece of aluminum, and this was 4-inch aluminum angle stock. And so I cut a piece here. It's 50 millimeters wide, and this depth here is about 27 millimeters coming out. So, and that fits right up inside this cavity in here. And then inside here there's another piece of aluminum. It's an aluminum angle that comes over to that and then goes up. So it's 58 millimeters high and 40 millimeters depth that way. So it's just cut it off, and then it's so I drilled a couple holes here, tapped them, and did the same thing inside there. There's two screws that come in this way to attach to this angle bracket, which brings it up, and then a couple holes here for this to go in. And then this can move back and forth, and these other two axes are fixed, so I had to get the depth just right for this. And it's quite solid, like nothing here wiggles around very much, so it gives you good readings. And the final axis is the Z-axis reading up and down here on the column. So I took the scale, mounted it basically as high as I could, and then didn't cut it at all. Went right down here as far as it could. And went on the principle of leaving these things as long as possible all the time. And then I took two of the brackets here, I guess 3, and have kind of just arranged them here such that, so this one is a little square bracket. So this is actually the piece that was cut off of the x-axis on the front. So I reused that. So it's mounted onto the reader. I've got a couple of holes here that I tapped into the side of that. So that puts that there. I have this going back and forth so I can move it in and out. And then I have a block that I mounted right onto this side of the piece here that moves up and down. And so that's mounted on there. So I can move this in and out. And that just gives me my reading as that goes up and down. And that, of course, is summed. So there's the, I don't remember what they call it, X, Y, Z, and U axis or something like that. So that this axis is summed together with the quill axis, and those two together give you the Z reading up here on the DRO. And then all of these have covers that go on there, so we'll talk about that. Okay, so on the x-axis in front here, they give you these kind of covers. which you can cut and reuse any way you want. So that's sort of basically what they come like. There's no holes drilled. They're not making any assumptions about how wide these things will be or anything like that. So this one on front, I have it set. It comes in here, and I made a couple holes here. And they give you screws to go in there, little standard slot screws. They're all a bit long, so I had to trim each one of them off, so I'm not sure what they were thinking with that. But there's a threaded spot right here in this bracket at the end of the readout. So you just drill a hole right there. And then what I did on this one is cut off this bottom part here, this bottom thing, and that gives me room down here to access these two set screws here, so I can lock the x-axis anytime I want, and it gives me clearance. That little lip that came out here interfered with this when you had it all the way out, so that gives me all the clearance I need now, and it keeps all the debris off of the scale. That's that axis. Now this one I haven't quite figured out what to do yet. At this point in time, I simply slide this in, and it kind of goes in across there. It stays in place as the thing moves and all that. So I don't even have to drill a hole or anything. I just cut it to the right length, and it keeps the debris off the scale down here. For the quill, remember I put an aluminum plate here, and I've got a little piece that goes right over there. Now that little mounting screw kind of interfered, so I just made a little cutout there, and that piece just fits on like that. And I'm probably going to take off this extra little bit right here. One thing that I should mention that I kind of goofed up was there's a fine adjustment screw here to adjust the height here, and that is interfering, so all I have to do is kind of trim away this a little bit. Just haven't bothered doing that yet. I don't ever use that screw. So that one goes on there, and then same at the back. There's just a simple cover that goes over it. Drill it out to the right size. You have to cut these little screws off a little bit so they fit in properly, and off you go. That sets up the 4-axis DRO on a Grizzly G0704, and it's a DRO Pro DROs.